Okay, so for today we're going to dive into lesson number 3, which is decimals. So we're going to try to explore different kinds of numbers. So the first set of numbers, or the kind of numbers that we did before, was the integers. Now we're going to get into decimals. I just want to kind of give you a little bit of how we started the number system, okay? Like, we've expanded our number system. We started from very basic. Now it got expanded on to different kinds of numbers. So I'll start off with that to kind of give us the idea of what we have learned before and where we're going, because that's important. So back in the day, so this is a numbers system. Number system. When we first started learning about numbers, we started off with, I'm going to start with a number line because that's where we're going to be. The very first thing that we learned about numbers, probably you do that for your own children, is that we started with natural numbers, right? What's a natural way of counting? What's a natural way of counting? How did you count? One, right? The natural way of counting would be 1, 2, 3. And then you teach your kids how to count the jelly beans, count the apples, count the steps, right? Our natural number starts with 1. So we started off with 1, 2, 3, 4, 5, and then so on, right? Those are the natural numbers. Natural numbers. I'll write it down later. And then, what did we do? We've expanded the number system with what we call a whole number. A whole number. And the whole number is introducing the concept of 0. So our whole numbers are 0, 1, 2, 3, 4, 5, and so on. Okay? So we've expanded it from natural to whole number. The whole number includes a 0 as well. Now, we didn't stop there, right? We looked at, after that, we looked at the integers. And integers are what? Whole numbers, but it's in the negative side as well. So we introduce our integers, so that integers are -1, -2, -3, -4, -5, and then so on that way. Now, from here, so far we have natural number, we have whole number, we have the negative numbers for the integers. What's next? Well, the concept of in-between numbers. So in between here, in between 0 and 1, can you think of a number that's in between 0 and 1? The decimal, yeah, the decimal. Anything else that you can think of that's between 0 and 1? 0.2, 0.3, 0.6, yeah, that's right. We got the decimal part. And we also have the fractions, like a half, right? In between would be a half, a third, a quarter, and so on, right? So in between these 0 and 1, there could be infinitely many numbers, because you could have many numbers in between 0 and 1. In between are the rational numbers, which includes fractions and decimals. So we start off with, so we first started with a natural number. And natural numbers are 1, 2, 3, 4, 5. And then we talked about whole numbers. Whole numbers are the 0 and all of that. And then we introduced and expanded our family of numbers to the integers, which becomes like -5, -4, -3. And it continues on to the left and it continues on to the right. And then the in-between numbers are actually called rational numbers. Rational numbers, and that includes fractions and decimals. Okay, fractions and decimals. So, and then there's other kinds of numbers. Okay, other kinds of numbers are irrational numbers. And these are the numbers that cannot be written as fractions. Okay, and I'll give an example of that would be a square root of 2. I'm sure somebody in this room knows this symbol.
This is pi.
This is pi, right? Pi, right? You have that on your calculator. Pi is, okay, so that's, okay, those are a few things that are irrational numbers, something that you cannot write as a fraction. So that gets us to now some kind of a little bit of an explanation of where the decimals are. The decimals are like in between, if you think of it that way. So we have everything. So we use decimal numbers every day when we deal with money, which is nice, right? Because anybody here who doesn't deal with money? Everybody deals with money. And everybody likes to have money, right?
It's a moolah.
Moolah, yeah. Also named moolah. So we also encounter decimal numbers when we measure weights, times, distances, medication amounts, and there's so many. So most of the decimal numbers we use in this course will be rounded to how many decimal places? 2 decimal places. Will be rounded off to 2 decimal places. But the number of decimal places required in a question can vary. So you should be able to round the decimal. Like, what does it mean by round? And we'll talk about that right away. So let me take a look at this. I'll just move this up. Is that okay? So going over here, is that okay? Yeah? People who are still copying that piece. Now here, it's the first one here. This is an example of 2 decimal places. Why is it called 2 decimal places? I really see 4 numbers, but what does it mean by 2 decimal places? Yeah.
Is that rounding?
Rounding to 2. When we say 2 decimal places, because it says here 2 decimal, right? 2 decimal places. When we say 2 decimal places, you're looking at how many numbers after the decimal, right? There are 2 numbers, so 2 numbers here, 2 digits after the decimal. That's why it's called 2 decimal places. Now, if we go over here, how many decimal places is that? That's 3 decimal places because there are 3 if I say, round off to 1 decimal place? How many numbers after the decimal? Just 1. Okay, so I'm just going to give this as an example. What would this be? Okay, I'm going to write it down. How many decimal places is this? 2, right? 2. How many decimal places is that? 1, right? 1. So we only look at the how many numbers after the decimal. That's why it's decimal places. So this is 2 decimal places. And then this is 1 decimal place. Okay. So each decimal has a place value. Has a place value. Now, what is the place value? Still on it. Place value. Tenth, hundredth, thousandth. Yeah. Yeah. So we have the place values in here. So tenth, hundredth, thousand, 10,000. Now, let me explain that before we get into that piece, okay? So let's say this is, I'm gonna make a ruler here, but it's like a giant ruler. This is my giant ruler from 0 to 1. Okay, 0 to 1. Now, when we say tenth, means from here to here, there are 10 equal parts. Tenth means 10 equal parts. So here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when we say tenth, it means that the piece is broken into 10 parts. Okay, 10 equal parts to be. Okay, it's supposed to be equal parts. So this is tenth. Now okay, again, this is my ruler, my giant ruler. Now, if we have hundredths, or hundredth with a th at the end, how many equal parts would that be?
10 hundredths.
Liquid. This is tenth. The tenth has 10 equal parts. If we have hundreds, how many equal parts would there be? 10 times 10, which is 100. Yeah. So when you see 100th, that means this piece of a ruler from 0 to 1 got cut or broken into 100 tiny pieces. Now, it's going to be hard to do 100 in here. Okay, so I'll try. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, that's only 10th, right? 100th. How can I do that? I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this tiny piece, tiny sliver, that's 100th, right? And then I'm gonna 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. like little ones. There should be 10 in each one. Now, before we get into the place values, I want us to think about tenth. So, or hundredths. Tenth and hundredths. Okay, so which one is bigger? Tenth or hundredth? Which piece is bigger? Tenth or hundred?
Good morning.
Hello.
Hi, we do have a party.
Yes, yes.
Yeah.
Yeah, that was easy. Okay, sorry, let's go back to that last bit. You can leave the stuff there if you want. Are you coming back? Yeah, leave your stuff here. So as you can see, which piece is bigger? 10, right? Because this is the 10th, and 100 is like really tiny. Yeah. I'm not gonna try to attempt the next one. Right? That's the next one. If this is, okay, I'll actually finish that off. So 100th means the piece is broken into 100 equal parts or pieces. Okay. So far so good? What I'm trying to do here is that I want us to visualize that the 10th is bigger than the 100th. Now what about the 1000th? Here's a okay, so when we have the place value of the 1000th, how many tiny pieces would that be? 100 means 100th means 100 equal pieces. Yeah, 100 times 10. So that's going to be means the piece, oh yikes, the piece is broken, yeah, into 1,000 equal pieces. I'll just go equal pieces. Yeah, this is gonna be crazy. I can't possibly create 1,000 lines, 1,000 ticks. So, but I want us to think about thousandth. That's a piece of it, right? Okay. So, thousand or equal pieces.
I should have never said that, because most likely you'll make us do it.
Oh yeah, if I do it, then you guys have to do it. Like, draw 1,000. And that's a big line, right? Because if we have a ruler, let's see if we can find a ruler in here. Can you imagine how tiny this is? Okay, I got this one. This is the one that I can find at the moment here. This is a, okay, zoom this in a bit. Okay, so this is from 0 to 1. That's 0 to 1 centimeter. Can you see how many pieces are broken in here? 10. So those are a tenth of a centimeters, right? They don't have, yeah, that's going to be really tiny if we do the hundredths. Good. I want us to just take the time to do that. If I just say, okay, one decimal place is this, two decimal is that, yeah, we might not fully see that in our mind. Okay, so now that we know how to do that piece, is it okay if I move it up? Yeah, move it away. Over here. So this one, so over here are ones, tens, hundreds, thousands, and thousands. Okay, we know how to do those ones, right? So this is a whole number. These are all whole number. Decimal and 3.25. Let's do that piece here. 3.25 tenths and hundreds. So the 3 is in the ones place, 2 tenths, and then 25 hundredths. Okay, so we would say that as 3.25, yeah, but the a fancy way of saying this, which we don't usually say it, is 3 and 25 hundredths. Okay, so if we were to say this properly, because we normally just say 3.25, the proper way would be 3, the decimal says, and 25 hundredths. What would this be? How can we say that? It's 145, we're going to go 145.1068, right? So some people might want to say it like that, but the proper way would be 145, and that's where the decimal is, 10,068, 10,068 would be 10,068 eighths with a TH. Okay, what would this be if we were to say this as 24.079, right? How can we say that? 24 and 79 thousandths. Okay, thousandths. So the very last one is the thousandths, so 79 thousandths. Good? That's okay. And people still understand you if you say 3.25. That's okay. Okay, let's take a look at example number 1. It says here, put them in order. Order the following decimal numbers from smallest to largest. Okay. Remember, the further you are going this way, the smaller the value gets, right? So here, it's 11.2, 10.375, 11.02, and 10. Now, which one? Are these two the same? No, right? No. If we were to look at that money-wise, if we look at this money-wise, this one would be 11.2, and if we do money-wise in 2 decimal places, it's going to be 11.20, $11.20, right? What would this be? $11.02. So which one is more? 11.2. Okay. So order the following decimal numbers from smallest to largest. So which one's the smallest of all these 4? The 10. Okay, 10. What's the next one? This is 10, and then these are both 10. Which one is bigger? This is a smaller one, and then this is 10 and a little bit, right? So this is 10, and then this is 10 and a little bit more. Okay, so this is going to be next. So 10 and 375,000, or 10.375. Okay, what's the next one? Oh, sorry?
11.02.
11.02, and then finally 11.2, or 11 and 2/10. That's good. Is that okay?
So can you use it on the
Leave it on, okay. Okay. So, if you just flip to the next page, okay, what does the next page say? I'm gonna leave it on for somebody to write that down. Looking at the next page, what does that look like? It says there. Rounding. Now that we can put things in order, now we're gonna round. And then remember, rounding to decimal numbers, we're going to be rounding up or rounding down. Okay? I'll get to the rules on when to round up and to round down. Is it okay to move it up or flip it?
almost.
Almost, okay. Yeah, okay.
Go ahead.
Go ahead. Okay, thank you. So rounding decimal numbers. It says here, when your calculator gives you an answer, sometimes they give you a long list of digits, right? After the decimal, you are instructed to round to 2 decimal places. Inspect the third decimal digit. If the third decimal digit is 5 or greater, then we round to the next number up, right? And then if the third decimal digit was less than 5, we round down. So, rounding up, rounding down. So for example, this is the number that we got on our calculator. And if we were to round to 2 decimal places, just gonna write that down in here, 26.1732. And we want to cut it off to 2 decimal places. This is where we're going to finish, right? 2 decimal places.
You can take off the last one.
Yeah, we're going to take off the last one, but we're going to see if we're going to have enough to round it up or round it down. So, this is the 2. We're going to look at the third. Okay? So, this is 5 or more. We're going to round this up. Okay? And it's if this third number is 5 or if it's less than 5, then we're going to round down. So this number is less than 5. So we're going to just round it down to 26.17. 26.17. Let's do this piece. 327.4158. We're rounding it off to 2 decimal places. So 2 decimal places is here, right? 2 decimal places is there. So which one do we look at? We're going to look at the number after those 2 decimal places. And then we're going to decide. So this one, I see that it's 5 or more. Okay? Then that means we have enough to round the 1 to the next level up. So it would be rounded up to 327.42. Is that okay? Let's try this one. Round the following to 2 decimal places. Okay, 2 decimal places. I'm going to be right there. That's 2 decimal places. But then I'm going to look at the number after those 2. I see that this is 7. So is it round up or round down? Round up or stay the same basically? Round up, right? Because it's more than 5. So it would become 2089.49. We're going to round up the 8 to the next number up. Is everybody okay? Okay, next one. 2 decimal places. How far do we go for 2 decimal places? So up to the 3, right? Up to the 3. Which one do we look at? We'll look at the 4. Now we gotta decide. Do we want to leave it as 3 or do we round it up to 4? Okay. Round up or round down? Round down. So it's gonna be 0.13. Now this number, the third number is 4. Right? It's less than 5. If it's less than 5, you round down. Round down means get rid of the other numbers. Okay, good. Letter C. 2 decimal places. Right there, up to the 8. Which one are we going to look at so that we can decide? We're going to look at the 5 to help us decide. Remember, if it's 5 and up, we're going to round up. So what would this be? 37.29. Okay, it's not 28 anymore. It's going to be 29 because we've rounded it up. Oh, this is a really tricky, funny one. 2 decimal places. Where's the 2 decimal places? The 99. And then we're going to look at the third one. Okay. If the third one is 5 and up, we're going to round up. If it's less than 5, we round down. So this one would be rounded up to what? Now this will be, the 9 will be rounded up to 10, right? Now if this is rounded up to 10, then this gets rounded up to 10 as well. And then that becomes 2.00. So 2.00. Last but not the least, for this one, 2 decimal places. So negative 2.81. 2 decimal places is the 0.81. Okay, and then we look at that one. The third number, is that going to be rounded up or down? Up. Rounded up. Okay, what does it round up to?
2.82.
Negative 2.82. Yeah. Okay, how's that one? Is that okay? Yeah, pretty cool, right? And we're going to see quite a bit of this when we do some. Okay, now, so those example 1 questions, those are rounding off to 2 decimal places only. Now over here, example number 2, we're going to round the following to indicated decimal places. Okay? It says here, this is the number, and then we're going to round it to the nearest 10th. Okay? When we see the word 10th, that's 1 decimal place. Okay. So do you want to go ahead and write down your answer there? Write down your answer there, and then turn to somebody and talk to that somebody. If you're whoever you're. Okay. Yes, write it down. Talk to somebody there, and then see who, like, what they wrote down. If they're listening to their reviews. I think it's just a matter of time before we get that going. Okay, so here we go. Ready? So it says here, nearest tenth, which is 1 decimal place. Nearest tenth, which is 1 decimal place. So this is, I'm going to be 1 decimal is the 6 there. Then what we're going to do is we're going to look at the number beside the 6, which is right there. If the number that I circled, or the number you circled is 5 or more, you would round up. So is it 5 or more?
More.
Yeah, it's 5 or more, yeah. So then it's going to be rounded up to 17.7, exactly. Okay, next one. Nearest tenth, which is 1 decimal place. 1 decimal place is there, right? 1 bit after the decimal. And then you look at the number right beside it. Look at the circle. So if this is 5 or more, you round up. If it's less than 5, you round down. So this is more, right? So that would become 4456 decimal 9, because it would be rounded up. Okay. The next one, nearest hundredth means 2 decimal places. 2 decimal places. I'm gonna circle the third. Okay. The one that I circled is more than 5, so that would be 0.28. What about the next one? What did you get for the next one? 0.33. Good. 2 decimal places. What about this one? This is funny because it says here nearest centimeter, which is 0 digits. So no digits. No decimal digits, rather. So this is your nearest whole number. You look at the digit. So if it's 5 or more, it's up. Less than 5, it's down. So this would be rounded off to 15 centimeters. What about this one? The nearest would be, nearest whole number would be 16 kilogram. Nearest dollar, what would this be? That means the closest dollar. $4. Yeah, $4. And this one would be the nearest degree. So that means 0 decimal places. Would be the closest would be 57 degrees Celsius. Okay, yay. That's exciting. So we're going to be rounding in 10th, 100th, or nearest whole number, no decimal places. How's that going for you? It's okay?
Teacher, can you give them?
Leave them on the other side. Okay.
Thank you.
No, it's okay. It's okay. How about this? I rip up my page and then I'll move to example. Okay? Organize my stuff. No big deal. I could just rip mine off and then there. So let's take a look at example number 3. Now we learned about the decimals and then we talked about putting them in order, rounding. Let's see this one. So Jennifer bought 2 liters of milk for a camping trip. The trip lasts for 6 days. How many liters of milk can she drink each day if she wants the milk to last the whole trip? Okay, so she bought 2 liters of milk and then she wants it to last for 6 days. So what operation do we have here? The 2 liters of milk has to spread out for 6 days. What do you think is the operation there? Division, right? You're going to divide it up so that you can have a little bit each day. So it's going to be 2 liters, yes, divided by 6. Okay, 6 days. So that's going to be, okay, I think it's going to be 2 divided by 6. It's going to be 0.3333333, right? Now, if you were to round it off to 2 decimal places, what would it be? Would be rounded off to 0.33 liters per day. So she can drink about 1/3 of a liter per day. 0.33. Let's take a look at example 4. Is that okay? Not too fast. Oh, I like this question. A group of 9 children entering a museum and paid $56.25 for admission. A group of 5 adults paid $68.75 for admission. Calculate the price for a child and the price for adult. Let's see here. A group of 9 children paid $56. 9 children for $56.25. And then 5 adults paid $68. How much is each child and each adult? How do you? Okay, and how did you come to that? Okay, so it would be 56.25 divided by 9, right? So 56.25 divided by for all 9 children, and that's going to give you $6.25 per child. And what about for adults? $13.75. And how did you come to that conclusion?
68.75 divided by 5.
Correct. Okay, so 68.75 for 5 people, from 5 adults, and it's $13.75 per adult. Is that okay? Any questions there? I'm actually going to put something here. Children, adult. Any questions? So far, so good. Last example here. Corinne bought 2 cases of soup. 2 cases of soup. There are 24 cans in each case, and each can contains 398 ml of soup. How many milliliters of soup did she buy in total? Now, any idea on how we can do this? Okay, can you envision this in our mind? Okay.
2 times 24 equals 48. Multiplied by 398 milliliters.
So each case has 24 cans in each case. So 24 in here, and there's 24 in there. So it's 2 times 24. So that's going to give us 48 cans. And now each can contains 398 ml. So 48 times 398. 19,104. Okay, what do you think our unit would be? So 2 cases times 24 cans in each case, it's going to be 48 cans. 48 cans times 398 ml. What would this be?
19.
19,104, yeah. And what's our unit?
Million.
Milliliters, yes, ml. Now here's a little bit of conversion. It says here, how many liters of soup did she buy? So this is ml, but now the question is, how many liters is that? And it says here, remember that at every 1,000 ml is a liter.
Divide by 1,000.
Divided by 1,000. So 19,104 divided by 1,000, 19.104 liters. Is that good? How do you feel about that one? It's not so bad? Yeah? So, that concludes our notes for today. So what we're gonna do is, as for assignment for your long weekend, because I don't see you for 3 days, don't I? Give me a chance to miss everyone. Okay, so for your assignment, homework, I'm going to ask you to complete, okay, try all of these questions on page 12 and page 13, okay. I know these are for you to try, for you to practice, and then on, let's say Monday, but it's not Monday, on Tuesday, you will go over and make sure that everyone's good at that. Then, when we want to do bigger and better things after that. Okay, so you got your notes, you got your homework to go with you.